super excited to be here. It's actually really cool. So Cape Town is kind of like, for me at least, a little bit like somewhat the home of curation markets. And like here we are today, so it's really excited to do this in Cape Town. Cool. So I think I'm just going to start diving in. Let's see, wait, that's the end. Okay, cool. So kind of just what I want to talk to you about. Also I'm from a project called Molecule, and also like founded Linum Labs together with Devin, who's also in the crew here. And then we started working deeply on Molecule sometime early last year. And so Molecule is applying a lot of these concepts, but I don't want to make the conversation too much about Molecule, but rather teaching you about like what these systems can do. So we want to talk about coordination marketplaces in general, and the coordination marketplaces that we know today in our current economy. Then go into curation markets and bonding curves, into engineering parameters specifically for bonding curves, kind of like what are all the different angles that we can pull at them to make them do different things. Then be engineering incentives with them and like system design. Then something that's really, really exciting, a new design that has come up that combines a lot of this thinking from Jeff, who's actually here, and Griff, and Michael Zagam, and Abby from Giveth, who are applying these systems. And then talk a little bit about Molecule and kind of what the system goals are there. Cool. Okay, coordination marketplaces. Just want to get a quick hands up. Who used probably either 3 of these? There's no Amazon in South Africa, but like who used these today? Literally this very day. Like I got here with an Uber and I'm staying in an Airbnb. Anyway, like why is that important? So we have coordination marketplaces today. So systems like Airbnb coordinate, build two-sided marketplaces that coordinate nice houses or like nice places to stay for people to when they go to places, and for me to easily find a place. Same for an Uber, it easily connects me with a driver. So it's a coordination marketplace. Facebook and Amazon also coordinate for different outcomes. So if you think about how Amazon first came out, it was a marketplace for people to either to have curated listings from Amazon or for me as a vendor to list my stuff. So what is the outcome of a listing like that? Is for me to access cheaper goods or find a nice place or easily connect with a driver. In principle, that's a really great thing. Like technology is amazing in that regard in what it can do. But we also know that there's a lot of problems with how these marketplaces coordinate. So increasingly, Facebook kind of is an interesting coordination marketplace. There's multiple angles to play at it from, but like increasingly we know that there's a lot of issues with how these marketplaces operate. And then on the other side, we have these decentralized coordination marketplaces coming up. And for me, curation markets is really one of the like leading design elements in how these new coordination markets come about. So if we take Ocean, for example, Ocean is really interesting. It's a system that coordinates all of its participants to curate the most valuable data sets for, ideally for AI and machine learning as a use case. But so the system as a whole, you put data in like as a user, and other users like curate those data sets with you. In the same way that on Facebook, I can make a post, and then other users help curate the success of that post, and then we kind of benefit because we have good posts. Then there's projects like there's Giveth, which is building a commons stack, so to fund, not just philanthropic project, but impactful project, and build sustainable coordination mechanisms around that. There's Foam. How many of you know Foam? Cool. Okay, most people know Foam. So Foam is trying to curate points of interest on a list, kind of taking on the role of a decentralized Google. So there's a lot of different projects that are kind of going this new coordination route. And so this is kind of a concept that I've been thinking about over the past few days. Is like we see this increasingly as a system design perspective. Is like how can we enable decentralized coordination? So users in these systems coordinate towards desired outcomes, better data sets, for example, or better drugs. Ownership and reward of successful outcomes is distributed. That means all of the users have more skin in the game. And the system design increases the likelihood of success and produces better outcomes. So that's the underlying thinking. So how do curation markets come into this? So if we look at what is the tech stack for these systems, so curation markets can help drive attention towards desired outcomes. So I might have a lot of data sets, but a lot of them are just garbage. So like creating a system that drives towards the desired outcomes, then having elements of continuous funding. So if we find an interesting outcome in a system, how do we drive finance towards it so that it can be successful? And then elements of governance and DAOs. So if we now get financing towards those outcomes, how do we coordinate the financing? And then elements of DeFi. So how do we easily power those funding mechanics? Because we could have this entire thing, but without, like, we could have all of this, but if we then need to go to like a financial market and be like, we have this whole thing, like, can you please help us get money for it? They'll be like, what is the system and what is the stack? And we definitely can't fund this. So this part is really important, and it's actually like DeFi and things like DAI and Maker, CDPs are enabling a lot of this innovation to start happening. So there's all of these different projects, and they're starting to plug into each other. And then last, I think harbor taxes are also really interesting to solve some of the free rider problems that we'll have when people invest in these markets. Cool. And now I want to bring it back into curation markets, but that's just like, why are curation markets interesting? I think they can be like one of the leading attention drivers to actually get us to focus on what is important. Like, what causes should we be funding? What, yeah. Cool. So what are curation markets? This is a definition from Simon. So curation markets reduce information asymmetry in the market through the usage of novel skin in the game signals generated through the use of tokenized crypto economic incentive games. It's an older definition, but I always really liked it because it sounds really complicated, but it's actually really easy. I think in the next sentence you want to say market participants put their money where their mouth is. And we know the concept of putting your money where your mouth is. That's kind of like the stock market. But in this case, we can abstract what we're actually buying in these markets. And we abstract it by saying we're paying attention to a specific thing. And that's where kind of meme markets were really interesting. Because with a meme, like memes become like, go viral. And so they rise in popularity because more and more people start paying attention to a specific meme. And so the original thinking, and correct me if I'm wrong, was like, if we get people to trade on the popularity of a meme by paying attention to it, the success of that meme like rises. And early, like if I stake on the right meme early on, I can actually make money off of it, and that would be kind of cool. So maybe at some distant day in the future we'll have meme traders. Cool. So the market's currency is now a proxy for its attention, and this then goes into bonding curves later on. The most two prominent design patterns that we have in curation markets today are one, token curated registries, things like Pharma is using, and then token bonding curves. I thought initially when I designed this thing that I was going to do both, but I would rather just focus on bonding curves because otherwise it gets too complex. Cool. Essentially, with the token curated registry, you have a long list, and participants kind of curate the list by again putting their money where their mouth is. Yeah. Cool. So bonding curves. What are they? They're really an economic incentive. They're economic incentive coordination tools. They're also autonomous market makers. What is an autonomous market maker? We have to imagine whenever we have a traditional financial market, there's someone making that market initially. So we need to bootstrap a buy side and a sell side. And that's why a lot of the unfortunate tokens that were launched over a year ago, there was never really interested market makers around them, which is why you have really low liquidity on some of these things. Because market making is hard. It's why we have this whole existing financial infrastructure of investment banks and exchanges that kind of finance all of these things. So the power with autonomous market makers is we don't need that. We kind of give that power to a smart contract that controls buying and selling. And we'll get into that. So curation markets also reduce information asymmetry. So because something is now publicly traded, people have an incentive to put stuff about it into the open. And I think they're really cool because with these design systems, we can get people and systems to behave in new ways. Then goes into coordination systems. Cool. What is a token bonding curve contract? So super quick recap. In the most current design, a bonding curve contract accepts Ether or an ERC20. so DAI, for example, in exchange for minting a new token of its denomination. So you send Ether or DAI to the contract, and it will mint you a token. It holds that Ether or ERC20 in a reserve, so that doesn't get spent. It's not like an ICO where I'm raising money. I'm trading with the contract. The contract buys and sells, but it keeps the money. And I can freely sell at any point as well. So how does buying and selling really work? So this is the most common picture that you'll see with a bonding curve. And it's also problematic because this is how we imagine the whole UX and UI at the moment. I'll get to that later. Like, we have a lot of work to do on that. But like, so you have a price, the price per token, which is the y-axis, is bonded to a number of tokens in circulation, so the supply, on the x-axis. And then you have a function that defines a slope. So if you're trading with this contract, you're always trading up and down this curve. Everyone who is new, was that clear? So I'm buying and selling with the contract. The price can move up or down. Maybe I bought in here, and then a few more people bought in here, and then I'm like, wow, I just made so much money. Sell, and the price goes down again. Yeah?
I think it's important to add in the circumstances that in traditional stock markets, when you buy and sell, it's like you're just giving the stock to someone else. But in this case, when you sell it into this smart contract again, the stock or whatever token you have is actually disappearing from the supply.
Yeah.
From the supply. So that's a big difference. So there's buying and selling happening through this market maker, but the important thing is that when it's sold, this thing disappears again from the supply. So it grows and shrinks as there is demand for whatever this token represents.
Yeah. And that's a really good point to add. And another point to add is in traditional stock markets, or even like think of crypto markets, the actual market cap of something isn't the liquidity. So let's say if crypto markets today, I don't know where they're at, but like let's say the entire market is at $200 billion. If, I don't know, quantum computing broke cryptography tomorrow, there'd be a lot of other problems. But like, if everyone started to try and sell their crypto at the same time, people could maybe get like $10 to $20 billion out of exchanges. Because if everyone starts selling, then like you can't actually get out that liquidity. With this, if you start selling, there is liquidity in the contract. Like the contract always has exactly that liquidity pool that people put in. It doesn't go anywhere, at least in its most vanilla design. Cool. So now that we've looked at the basics, this is kind of an overview that I did a while ago, just looking at the different parameters that we can change. So now there's the space contract, but we can start fiddling around with all of these different parameters. So one of them is the issuance. So, or think of it first like it's a token bonding. So they're token bonding curves. So on the token side, we can change the issuance. So the issuance is like what tokens is this contract issuing? It can issue ERC20s. That's the most common design. It can also issue ERC 721. So you could have a bonding curve that issues CryptoKitties if you wanted to. First thing, so this we can change this. Then the supply, the total supply of tokens that it can issue, the supply could be infinite. It could be capped at, say, 100 million. And there's also emerging designs coming up with like negative supply, where we can now, well, not negative supply directly, but where we can short the contract itself. The next part is the bonding. Like, what are we bonding into the contract? The one part is the collateral, so the underlying reserve. I can trade, for example, with a contract with DAI. It could be ETH. It could be other ERCs. Ocean, for example, is using their native token as the native token that is staked into their bonding curves. So what type of collateral goes in? And then this is actually, I think, the asset or the objective of the curve is the most interesting part, or one of the most interesting features. So the asset is, what are we actually trading here? Because we can do this for anything. We could link it to an NFT. No, we could link it to a meme, and then we're trading this meme. We could define an objective that we want to clean up this beach in Thailand. Or we could say this represents a CryptoKitty, or the way that we're using it at Molecule. In our case, the underlying asset is represented by like a piece of IP, so a drug. In this case, we're trading a particular drug. So this will also likely define what your bonding curve contract means legally, because on the one side, if we're trading a meme, interest in a meme, what is that really? If we're funding a cause, then it's more like along the lines of crowdfunding. We could be selling concert tickets through this mechanism. But if we're saying we're now trading the value of our house or a stock, then it quickly moves it into like securities area, for example. So that's really interesting. Then the function, we can use quadratic functions, linear functions, sigmoidal functions, sinusoidal functions. Like the math, the boundaries of what functions you can use are really just the math. But there's a lot of modeling that needs to go into that because you're now defining potentially the future of a market. And then the last part is the pricing. There's some really cool designs coming up with like, so in the vanilla design, I buy and sell on the same curve, but I can now implement a different buy and a sell curve. Or I can also just say on each buy, I'm leveraging a tax. So if you buy in, you automatically have to pay a tax of 5 or 10%. That can be used to fund the underlying asset. Is there any questions up until here? Cool. I'm going to go a bit deeper. So one example that we're working with, so the asset or the underlying objective, which there's a concept called refungibles. And refungibles are basically, let's take a non-fungible token and make it fungible again with a bonding curve. And this was first pioneered by Billy Rennekamp, I think in early last year, where he said, cool, let's move it, let's set the owner address of an NFT to a bonding curve contract. So the owner of an NFT says, I'm giving ownership away and I'm moving it to this bonding curve, and now you guys can trade attention in my CryptoKitty. But obviously this can represent a lot of stuff now depending on what the NFT represents. So the way that we're thinking about using this is like IP is usually based on patents and proprietary data. Let's just take that data and attach it to an NFT, boom, becomes tradable, and now you move that NFT into a bonding curve. Yeah, so that's one example.
You start issuing portions of this NFT, like of the ownership to
Yeah.
people that contributed.
Yeah. So now you're selling portions of the NFT essentially. That's one design pattern, and the way that we look at this, for example, is if this was a bonding curve, what you do is the creator now relinquishes ownership of his NFT. So let's say this is the value of the CryptoKitty. He says the CryptoKitty is worth $10,000, and I'm putting it in here, and I'm getting this first stake in all of the ERC20s in that contract. And now, henceforth, I don't own the NFT anymore. You guys can trade it. And at a later point, that guy, but he never paid anything for those first tokens. But the value of the tokens is represented in the value of the NFT. And then later on, he could get some of that out for funding. Yeah. Cool. The different curve functions, we kind of talked about that. We can have exponential functions, linear functions, role-based functions. Most of the work has been done around linear functions up until now because they're quite easy. Yeah, functions. One thing that I can say about functions is doing math on Solidity is really hard. I think George can speak to that.
I agree.
If you're having a lot of trouble doing it with Solidity, try doing it with Viper. I know that you guys have a really cool, really good repo on that out already.
Yeah.
Griff, you look very interested. Yeah, doing it in Viper might help. Yeah. Sigmoid we're really into sigmoid functions. We think they're quite cool. So they're S-shaped curve. They're best suited for markets that stabilize after a certain period or inflection point. They're commonly found in like population growth. Like you might have like if you I think it looks a little bit different, but if you put like rabbits and foxes into like a new place and both of the populations start growing, at some point the population like stabilizes and finds like a natural thing. And so S-shaped curves are often found in that kind of setup. And they're often found in like the development of different technology patterns. So that's what we're playing around with. I mentioned this, so this is kind of walking you through the different parameters. I mentioned this briefly. So like the pricing of the curve, we can implement different buy and sell structures. And again, there's a whole bunch of projects. We can have static pricing. There's dynamic pricing and taxation. There's individual pricing, where we actually price each person that trades with the bonding curve on an individual basis. And there's a concept that one of the guys at Ocean, which is called equilibrium bonding curves, which basically means everyone buys in the beginning, but no one is allowed to sell. And then everyone sets their buy price already when they buy in. And then afterwards, trading starts at some point, and the contract kind of sets an equilibrium price across all of those. Yeah?
Equilibrium means if I buy some tokens for one Ether, I can sell them and get one Ether exactly back.
No, so so equilibrium pricing in this equilibrium bonding curves in this sense means that the contract tries to stabilize, I think, the sell prices afterwards. So everyone can only buy in the beginning, but you define a price that you would be willing to sell at, and that then defines an equilibrium. I can send you an article on it. I'm not too deep in if Ocean has used it as a design parameter yet or not. But so in terms of playing around with parameters, there's a lot of work being done around that one. And then another one that we mentioned briefly is curve taxation. So if we implement a different, like let's say this is the buy curve and this is the sell curve. If my purchase price is at A, that means, and there's a tax, that means I can only sell at B at this point. So I have to get to C to be at a break even. And like the resulting collateral that is kind of being taxed can now be used for whatever you want to do with it. It could be, I don't know, it could be, for example, used to fund, an artist that has put his work up like this, and there's more and more attention being driven towards his work. Maybe the curve represents the underlying IP, and the artist uses this as a way to derive continuous revenue from the curve.
Continuous organization do exactly like this, but it's used for like funding companies.
Yeah.
Literally funding companies. You take the spread, put it into companies, and then you have more after this, but essentially it's the same.
Yeah. Yeah, Tibor has been doing some really cool work on continuous organizations. I don't know how we're doing on time. I've been going quite leisurely. Still, okay. Cool. Let's get crazy. Okay, so this has been built by people from the Giveth team and like this new really cool formation called the Common Stack. And what I really liked about this, even though it looks kind of crazy at the from the first glance, it really helped me kind of understand how some of these new tools are being put together. So this is a new design. There's a really cool article out by Abby Titkamp called Augmented Bonding Curves. And it looks quite complicated, but it's actually much simpler than you think. So you see up here, members contribute. So you can put die into a common bonding curve. What the bonding curve does, it puts that die, first of all, into a reserve, and it starts creating a supply of tokens. And now this is kind of the whole bonding curve part. So you put in die, the contract creates a reserve of the die and creates a supply of tokens. And now if I want to sell my tokens now, what the contract then does is it creates a liquidation, they call it a liquidation friction fee. So it basically takes a tax and it moves that tax into a common funding pool. And then there's a withdrawal function for that funding pool, and we can now we have a funding pool where we can allocate that to different causes that we're trying to fund. And what I thought was cool about this, it's really like the system components are on these two sides. On the one side, you've got this market maker that is now driving, coordinating towards this like goal. And on the other side, you've now bring in these funding and governance mechanisms. So now, if we have funding now, how do we allocate it? Which is like the coordination of funding decisions is like a huge thing in our world today. Yeah. So, and this for me like is an example of like how these different pieces of the stack are now coming together. Yeah. Any questions about this? Griff, do you want to?
No, I thought you nailed it.
Okay.
Just know that it takes a lot of design work to get the stuff right. So
Yeah. I think, yeah, this was month of work, and it's also continuously evolving. I just had a conversation with Jeff, and really excited to move this ahead. One danger that I see and this is with the work that I'm doing as well, is like one danger that I see is that you create rabbit holes on rabbit holes, when like we haven't even tested this, we haven't tested this part. Yeah, that's one of the things. We'll get to that. Like, unfortunately, there's no current working, fun to use live implementation of bonding curves today. Like there has been quite a few experiments on testnets and on a few on mainnets, but like a mass use of these systems that we still have to see. So if you're building anything that could be like easy to, I know one team is actually building something really cool. It's like a capture the flag bonding curve, where you've got two teams that are waging war against each other, trying to get to the top of the flag, and the first team to get to the top gets the collateral of the other team. I won't go too deep into it. Cool. How are we using it? Like, why do we think curation markets make sense for drug development in molecule? So these are the different stages of clinical trials. So you have the discovery stage, preclinical stage, phase 1, phase 2, phase 3, and then approval. The funding requirements across these stages literally goes up like a bonding curve as you move along. But that would be completely oversimplifying it. You have to imagine, so these are diagrams from like typical management consulting, like how ideas get developed in a firm. But imagine in the early stages, you have thousands of potential compounds to treat one disease target that you have. Thousands potential of drugs, combinations. And then kind of as the pipeline goes along, like very few drugs only make it through. And so in the early days of looking at this, I felt like this is a perfect use case for these curation markets and autonomous market makers, because you can put out, like, you can easily create these markets and let the crowd curate and place value on and trade on what actually might work. And then the other aspect is once you have those markets out in the open, now they try and solve information asymmetry, because as a market participant, I have an incentive to put data into the open that proves or disproves the success of a drug. Yeah, we moved away from this a little bit, but like in a very oversimplified sense, imagine this was a bonding curve. You go through the different stages: drug discovery, preclinical trials, clinical trials, and so on and so forth. And the curve, and this is why we like sigmoidal curves, the curve kind of mirrors the capital requirements that you have along those stages. So many drugs will never go beyond here. And you also see like here a drug is still like very low value because it has to prove itself. You need to start producing a lot of data about it. Producing the data specifically in preclinical trials is very expensive. So imagine here you have like a ton of potential compounds, and kind of it also moves down like that in terms of what actually might work. Cool. So how do these systems re-engineer economic incentives? And this is a little bit like our lens on it, but like, so bonding curves create openly curated markets that enable distributed price discovery. So we can now discover prices and value for these assets that we put on these systems. And that in return incentivizes open source research. And in our case, it makes negative data valuable, because in the same way that I can trade on the positivity of a market, I can say that drug is totally overvalued, and I have a data set here that proves that this is likely to fail. And now that negative data becomes valuable, because if I publish it, I could take a short position on a market, publish the data, and boom. The crowd curates and reveals data on valuable outcomes, which in return we now have patients and consumers that could take part in actually driving attention to what treatments they want to see on the market. I think pharma is, and Michael talked about it very well, pharma is famous for, first of all, extremely expensive drug development, but then also bringing really bad treatments to market. Like things like OxyContin, we could have very early on seen that this is highly addictive. There was actually data sufficient available that like this was going to be problematic. Nonetheless, it was pushed onto the market in mass. So if we can direct the crowd to say, hey, stop, like this might be problematic much earlier on, rather than just that power being within one company, that could be really cool. And then finally, frictionless market making in low liquidity environments. And this goes, I mean, this spans across various different fields, but like in IP specifically, IP is extremely low liquidity. It's very difficult to move these assets around, takes a lot of friction, and defining the price for them is even harder. Like defining an early piece patent on a drug is kind of like putting a finger in the wind and being like, well, it could be super successful here, it could treat that, but it's like you kind of plan into the future One famous example is a drug called, I think it's sildenafil, which is was developed by Pfizer to treat blood pressure. The brand name today is Viagra. So during the clinical trials, it was discovered that sildenafil actually was a great treatment for erectile dysfunction, which ballooned its potential market potential from just a blood pressure treatment, which was fairly low, to a multi-billion-dollar potential. So the pricing at this stage is extremely hard. But if you can make that discovery much more fluid by having people submit data out into the open, that could be really efficient. And the same way goes for things like funding common initiatives. If we can have kind of recursive data loops into these systems that curate information faster, because now I have an incentive to reveal information and bring it out there, then we can create systems that curate towards much better outcomes. I think. Oh, cool. Key challenges. We need much better UX and experimentation with these things. As I said, integrals and logarithms in Solidity are really hard. We need simulations and modeling and tools. I also know Giveth together with Block Science are working on some really cool simulation tools. If you're interested to get involved there, they're pioneering a tool called CatCat, and they need more testers. Then there's a lot of attack vectors still that we need to test through simulations, ideally, like pump and dumps and front running. Governance, I think, will be a big topic going forward. Like, we have this functioning market now. How can it govern itself? And then, as I said, the danger of like rabbit holes with these designs. Let's start with the basics and test those, and then go in deeper. Cool. Thanks.